In the world of computers, something really amazing is about to happen. It's called quantum AI. It's a mix of two incredible things, quantum computer and artificial intelligence. Imagine being able to solve incredibly hard problems in just a fraction of a second. And all the huge amounts of information we have won't be overwhelming anymore. Instead, they'll be like a fun playground for getting amazing insights with the power of quantum. Quantum AI isn't just another step in technology, it's like opening a whole new door of possibilities. It challenges what we think is possible with computers. We're right on the edge of this big change, so let's explore the tiny world of particles where intelligence isn't just artificial, but also really amazing in a quantum way. The dawn of quantum computing. But before we dive into the deep end, let's take a step back and explore the dawn of quantum computing. So, picture this, it's the mid-20th century, and classical computing is just starting to gain traction. Computers are these massive, clunky machines that crunch numbers using bits, tiny switches that can be either 0 or 1, like a light switch that's either on or off. But then, in the 1980s, along comes the idea of quantum computing, and suddenly, everything changes. Quantum computing defies the rules of classical physics and taps into the mind-bending properties of quantum mechanics. Instead of bits, quantum computers use qubits, quantum bits, which can exist in multiple states simultaneously thanks to a phenomenon called superposition. It's like flipping a coin and it landing on heads, tails, and everything in between, all at the same time. And if that's not mind-blowing enough, qubits can also become entangled, meaning the state of one qubit can instantly affect the state of another, no matter how far apart they are. It's like having a pair of magic dice that always roll the same number, no matter how far apart you take them. Now, you might be wondering, what's the big deal? So, qubits are a bit more flexible than classical bits. What's the fuss? Well, my friend, that's where the promise of quantum supremacy comes into play. You see, quantum computers have the potential to outperform classical computers in ways that are downright jaw-dropping. Take, for example, the task of factoring large numbers, something that's crucial for encryption methods like RSA. For a classical computer, this is like trying to find a needle in a haystack, but for a quantum computer, it's more like waving a magic wand and watching the answer appear before your eyes. That's the power of quantum computer, the ability to tackle problems that were once thought to be unsolvable or impossibly time-consuming for classical computers. But don't just take my word for it, let's compare the two. Imagine you have a mountain of data that needs to be sorted, analyzed, and crunched into actionable insights. For a classical computer, this is like climbing that mountain one step at a time, painstakingly sifting through each piece of data until you reach the summit. But for a quantum computer, it's like teleporting to the top in the blink of an eye, thanks to its ability to explore countless possibilities simultaneously. It's like comparing a horse and buggy to a rocket ship. Sure, they'll both get you where you need to go, but one will get you there a whole lot faster. With so much raw power at hand, what happened when quantum computer meet AI? Quantum AI. Let's start by unraveling the relationship between the two. At their core, both quantum computing and AI are all about processing information, crunching numbers, analyzing data, and making sense of the world around us. Now, traditional AI machine learning algorithms are like detectives, sifting through mountains of data to uncover hidden patterns and make predictions. But when faced with truly complex problems, even the most advanced classical algorithms can hit a brick wall. That's where quantum AI algorithms come into play. Designed specifically to harness the power of qubits, these algorithms can explore vast solution spaces, searching for needles in haystacks with a speed and precision that would make Watson jealous. But it's not just about speed, it's also about depth. Quantum simulations, in particular, offer a glimpse into a world beyond the reach of classical computers. Imagine being able to simulate the behavior of molecules with such fidelity that we can unravel the mysteries of chemistry, biology, and materials science at a level of detail that was once unimaginable. From designing new drugs to optimizing renewable energy technologies, the possibilities are as vast as the quantum realm itself. And let's not forget about quantum neural networks, a marriage of quantum computing and AI that's poised to revolutionize the field of deep learning. By leveraging the power of quantum entanglement and superposition, these networks promise to unlock new frontiers of pattern recognition and data analysis, paving the way for AI systems that can learn and adapt at speeds that would make even the Flash jealous. So, what all of this mean in real life? Real-world applications. First up, we've got quantum machine learning. Now, we all know how AI has been transforming industries left, right, and center, but imagine supercharging those AI models with quantum data. Quantum machine learning isn't just about speeding up the training process, although it does that too. Thanks to quantum parallelism, it's about tapping into the inherent quantum properties to unlock new frontiers of pattern recognition and data analysis. With quantum-enhanced algorithms, we can tackle complex problems with unprecedented efficiency and accuracy, paving the way for AI systems that can learn and adapt at speeds that would make even the most advanced classical systems blush. But wait, there's more. Quantum computing isn't just about making AI faster and smarter, it's also about tackling some of the most pressing challenges facing humanity today. Take drug discovery and materials science, for example. These fields are all about exploring the vast landscape of molecular structures, searching for that elusive cure or that groundbreaking material with properties straight out of science fiction. With quantum computing in the mix, researchers can simulate molecular interactions with unparalleled precision, accelerating the discovery process and opening doors to a new era of innovation in healthcare and materials science. Genome analysis is another frontier where quantum computing shines bright. Our DNA holds the blueprint of who we are, but deciphering its secrets is no easy feat. With quantum algorithms designed to sift through vast genomic datasets, researchers can unravel the genetic complexities underlying diseases, predict individual health risks, and optimize treatment strategies with a level of precision that was once unimaginable. We also have financial modeling. In the fast-paced world of finance, where every millisecond counts, having the edge can make all the difference between success and failure. Quantum AI isn't just a game changer here, it's a game breaker, revolutionizing risk management, portfolio optimization, and predictive analytics with lightning-fast computations and novel optimization techniques that leave traditional models in the dust. Solving the unsolvable. One of the most mind-bending aspects of quantum computing is its ability to tackle problems that were once thought to be unsolvable or, at the very least, impossibly time-consuming for classical computers. Take the traveling salesman problem, for instance. Picture a salesman trying to figure out the most efficient route to visit multiple cities, ensuring he hits each one only once and returns home without retracing his steps. Sounds simple, right? Well, for classical computers, as the number of cities increases, the number of possible routes explodes exponentially, making it a nightmare to compute. But for quantum computers, thanks to their ability to consider multiple possibilities simultaneously, finding the optimal route becomes a breeze. Then there's the graph coloring problem, a real brain teaser in the world of computer science. Imagine you have a graph representing a network of interconnected nodes, and you want to color each node in such a way that no two adjacent nodes share the same color, using the fewest colors possible. Seems like a headache? You bet. But quantum computing swoops in like a superhero, able to explore countless color combinations simultaneously, making short work of a problem that would leave classical computers scratching their heads for eons. Last, but certainly not least, we have protein folding, a challenge that's vital in the realm of drug development. Proteins are the building blocks of life, and understanding how they fold into intricate three-dimensional structures is key to unlocking the secrets of diseases and designing targeted therapies. This is a computational puzzle of epic proportions, but once again, quantum computing steps up to the plate, offering the promise of unraveling complex molecular structures with unprecedented speed and accuracy. What lies ahead? The intersection of quantum computing and AI is like a frontier town in the wild west of technology, brimming with potential but also riddled with unknowns. Quantum computing could be the key that unlocks the door to artificial general intelligence, AGI, a level of AI that can understand, learn, and apply knowledge in a way that's indistinguishable from human intelligence. As we wrap up this video, think of quantum computing as the engine that could power AI into uncharted territories, opening up endless possibilities for innovation and discovery. If you made it this far, write AI in the comment to let us know you received the information. To stay relevant in the age of AI, watch other videos from our channel. And don't forget to subscribe for more insights into the fascinating world of AI. See you in the next video.